My name is Patrick Smith. I'm a junior at Ohio State. My presentation is the impact of temperature on the NFL. So when discussing home field advantage, weather and temperature are often brought up. So I wanted to look at whether teams from quote unquote cold areas are better in cold games than teams from warm areas are. So to do this, I analyzed the impact that temperature had on expected points added, or EPA, over the last decade. And to do this, I divided teams into cold weather teams and warm weather teams, depending on what city they were from. So cold weather teams are teams that are from a city with an average temperature from September through December of less than 50 degrees. And this 50-degree threshold is somewhat arbitrary, but many of the preconceived cold teams fell below this threshold, so I felt it was fitting. I also divided games into cold and warm games based on game temperature. I originally used 32 degrees Fahrenheit as a threshold for cold games, but there were many teams that didn't play in a lot of games below this threshold, so I bumped it up to 40 degrees to try to get a more complete analysis. So I used data from the NFL FastStar package in R, and this package contains play-by-play data dating back to the 1999 season, but I was only focused on this past decade. It contains hundreds of variables for each play, but I was only interested in a select few. With this data, I excluded any play that wasn't a run or a pass play and any game that was played in a dome because I was only concerned with games that were affected by outdoor temperatures. I also used data from the National Oceanic and Atmospheric Administration, and this data contained monthly averages for many US cities, and then I used this to calculate the averages for each city temperature during the NFL season. So here's some summary statistics. As you can see, average game temperature was on around 60 degrees Fahrenheit. And EPA per play was close to zero. And then for the NFL city temperatures, the minimum value of 40.6 corresponds to Green Bay, and the max of 77.1 corresponds to Miami. And then here's some more summary statistics, except this time divided by game type, so cold games on top, warm games on the bottom. Interestingly, EPA is slightly higher for cold games, so I think that's something to note. And then here's some more summary statistics, this time for cold teams versus warm teams. And again, EPA is higher for cold teams regardless of game temperature. So I ran a regression for EPA per play using the equation shown. Um, and I included wind as a control variable. And then cold game is just a dummy variable for games below 40 degrees Fahrenheit. So 1 if it's below and then 0 if it's above. And then cold team is a dummy variable for teams from a city with an average temperature below 50 degrees Fahrenheit during the NFL season. And then so just a general interpretation, all else equal, beta 1 represents the change in EPA per play for a 1 degree Fahrenheit change in game temperature. So here's the regression results. As you can see, temperature is very close to zero, and because of its high p-value is not significant, so therefore it has very little to no effect on EPA per play. And then looking at the estimate for cold teams, EPA per play is higher for cold teams than warm teams, holding all else equal due to its low p-value. Here's a graph for EPA per play versus temperature for NFL games. The regression line was fit, and as you can see, there is not really much of a difference in EPA per play for different temperatures. So I also use jitter temperatures, which is just adding small values to each temperature to make the graph more visually pleasing. Since the regression results were a little underwhelming, I was interested in seeing if certain teams had higher EPA per plays in cold games. So I performed a z-test on the difference of EPA per play in cold games and the EPA per play in warm games for each team. So here's the two-sample z-test for the difference in EPA per play between cold games and warm games for each NFL team. So the red bars represent a warm city or warm team, and the blue bars represent a cold team or cold city. So only 3 teams were significantly better or worse in cold temperatures. These include Philadelphia, which was significantly worse, and then New Orleans and Arizona, which were significantly better. And this is interesting because Arizona and New Orleans both play in domes and are warm teams, but also Arizona and New Orleans only ran 193 and 464 plays respectively, which is less than most teams. So this might have something to do with why they had such a large Z statistic. So lastly, I ran another two-sample Z-test to see whether the EPA per play for cold teams was actually different than the EPA per play for warm teams in cold games. So just answering the question, are cold teams better in cold games? So here's a table for the comparison of cold teams versus warm teams in cold games. As you can see, there's a pretty big difference between EPA per play, and the test results in a Z statistic of 3.685, which is significant at a 5% significance level. So you can conclude that EPA per play for cold teams is in fact different than the EPA per play for warm teams in cold games. So in conclusion, all else equal, game temperature does not have an effect on EPA per play. However, cold teams do seem to be better in cold games in terms of EPA per play. And then just some limitations of the analysis. So I only controlled for wind. I didn't control for other weather conditions such as snow, sleet, rain. These are things that often can affect gameplay. Also, the R-squared value for the regression was very low, so it didn't explain much of the variation in EPA per play. Also, some teams, such as those that play in domes, played in very few cold games. Um, Minnesota, Detroit, and Indianapolis all play in domes, but were included as cold weather teams. And then some of the more dominant offenses over the last decade were cold teams. So New England, Green Bay, Denver, back with Peyton Manning, Pittsburgh. This might contribute to the overall higher EPA per play for cold teams over the last decade. And then lastly, there's a different number of plays run in each subset of games. So the majority of teams ran more plays in warm weather games just because they played in more warm weather games. So that's all I have. Thank you very much.